just I don't know. Let's see. We can talk about your pull request or something like that. I don't know.
Yeah, sure.
Because it seems to me that you are like up to a lot of things at the moment, and
well, I was only up to 2 things, but you start like pulling the threads, and more things come. Then you find a bug.
I know that. I know that. And it never stops.
Yeah, never ends.
It's a never-ending story, really. Yeah. And let's see, what do we have open?
Are there any updates on the conference, SU2 conference?
No, so the status is still well, we are at the moment trying to figure out how we collect all the contributions.
Okay. Because I got
We will mail, I guess, this week.
Before it was decided to make it fully virtual, I got an email from Juan, or at least signed by Juan, saying that instead of submitting a 20-minute or 30-minute presentation, I should aim for like a kind of longer.
You can. Okay. Yeah, that would be still the idea then, if you're interested in that. Also, like maybe going again over the OpenMP stuff, maybe some short introduction OpenMP. I don't know how familiar the people are with that. But we probably will finalize it this week or something like that, and then yeah.
Okay.
I will let you know, definitely. It will be the same date probably. So beginning, yeah. So somewhere at the 10th, between the 10th and 12th of June.
Hey guys.
Hey Giant.
Hey.
How's everyone doing?
Oh, fine, I would say.
Yeah.
Not too bad.
Not too bad. It's also British style. Could be better. Yeah, I mean, so there's nothing really planned, but
yeah.
So we have we have a couple of options what we could do. We can go through some of the pull requests, or we can discuss more the optimization thing, or we go through the config structure.
Ooh. I had I was one of the things that came up was thinking of a minimum viable product for the optimization.
Yeah.
And I was wondering if we could just discuss that for a second.
Of course, yes.
Because let me just, can I share my screen? I had written a couple of things down.
Yes, you can, of course.
Yeah. All right. Can you see this?
Yep.
Yes.
Okay. So what I thought of as basic, what we would want to see in something that we can push to master, basically, is what I was thinking about. And some of the things that we can work on that I think we should have in this first version. The first thing is accepting arbitrary objective function definitions. This is, I think this is achievable, and most of the way there with your expression language. I think just you making sure we can use that in the optimization framework would be a good.
Yeah, so the idea would be just to pass it, you just give it a string, and then it's just passed to the C++ part.
Yeah, exactly.
We just have to think how we do it with some geometric things.
Yeah, so that's one thing that I was thinking about, was if we can try and make a corollary, basically the same thing for that we have for the objective function, but for geometry. We don't necessarily have to have a full expression parser, but just being able to say like cross section or like thickness at this point, being able to specify to that level.
Yeah, it should be possible.
And running the SU2 Geo from that would be good.
So I have like different modules now in my branch, and it's very easy to like use that module for some other output as well. So
yeah, I think we just need to set it up like the way you've done it for the solvers, where you have different sets of fields for different solvers. I think we just need to have that for like a map for the solvers, right? You have so we need to have that for the geometry to see what can be specified, and yeah, basically the name. So like the way you do SU2 CFD-D and set that flag, and it gives you a list of outputs. Getting a list of geometry evaluation functions that are possible like that would be nice. And this also actually goes to something that Pedro mentioned in one of the in the channel, was even with design variables, being able to query what the available design variables are, I think is important to try and make this a long-lasting change that doesn't have, you don't have to add a switch case or an if every time we add a new design variable to a mix.
Yes. Yeah.
So that was from objective functions, and since we're trying to
but you only essentially, so I'm just thinking about like how does it make sense to combine geometry stuff with CFD stuff in one function? I don't think so, right? Well, maybe if you have some.
I think it might, because you might want to aggregate some constraints or something. I don't know.
Yeah. Because then you have to think about how you do that, right? Because if you write like an expression, then part of that expression comes from SU2 CFD and the other one from this other module, and then it gets a little bit tricky then, I guess.
Yeah.
But I don't know what the best way. But probably have to constrain it to like maybe some penalty method where you just sum up these different things or something like that. I don't know. It's hard to make it really general.
Were you thinking of mixing the two things, Jan? The geometry and the let's say fluid functions?
Sorry, I didn't catch that question.
What was the? Is there an example you can think of how those things would be combined? So you would say thickness plus drag, and I don't know.
Yeah. If you think like of a penalty function, then you might want to have that, right?
Yeah, but if it's penalties, we can implement easily on Python side.
Yeah. That's what I thought. That's what I meant with just like constraining it to like this penalty things where you have just like an addition, right? You just add things up with maybe some weights coming from the different like modules that you might have. Inside of SU2 CFD, of course, you're very flexible, but then on the outside, it's you're a little bit more constrained.
Yeah.
I think that's the only way how we can do it. Otherwise, we have to somehow mix this Python with this other language somehow, which I don't know. Other than it's also complicated, I guess.
Yeah.
But but for example, right now SU2 Geo computes like a bunch of functions by default, depending on application. It just goes through quite a big list of functions.
Yeah.
For that, maybe we could have some expressions. So within the geometric functions, maybe you could write expressions for that.
Yeah, I was thinking like instead. So the way it does is you specify either like a wing or an airfoil or a fuselage, and then it calculates a bunch of things based on that. And we could make it a little more specific where it doesn't have to calculate everything if you don't want everything, because then it also has to go through all of those when doing the finite differencing. So it has to recalculate everything.
The finite difference goes over the input variable, so it's the same, let's say. But if we wanted to use the discrete adjoint also for this, it would be better if we could have more control over how many functions we actually need to differentiate.
Yeah,
but it's hard if you have them in like an expression. That I also like figured that out now that I'm doing that for the solver, because you cannot like just look in the expression and, well, in theory you can actually. I thought about it. You just go through the expression and see what values you have, and then you compute these values. But it's a little bit tedious to
okay.
But the expressions are differentiable, no?
Yeah, of course they are differentiable. Yes. But it's hard to figure out what like values I use inside of that expression, right? So what I do at the moment is I just compute everything more or less, because I have to.
Yeah, but that's what SU2 CFD does. When you compute the force coefficient, you compute all of them, and not all of them might end up in the objective function.
Yes, that's what I like. Have to do also with the newer output structure that I'm working on. Also for the different markers, I have to compute it on all the markers. Although I only need it maybe for a couple of them, but there's no way in figuring that out directly, actually.
Yeah, I mean, shouldn't be a big thing, and we can always, go from the general case to the particular, or to the fine tuning.
Yeah,
but it's a good point. I will keep that in mind when I'm like with the current thing I'm working on, that we might want to use it also for the geometry stuff. It's a good point.
Yeah, and along with those changes, I mean, we also need some generalized geometry evaluation things. Everything is specific to airplanes right now, and some of it is already generalizable, where it takes a cross section of a wing and makes it into an airfoil. Like that can be done for any sort of geometry. It doesn't have to be a wing. And then you have all these cross section variables and area variables that you can calculate for all of those.
But is it already in a general way at the moment?
So what it does is it takes a plane, it calculates all the edges that plane cuts through on the wing, and then reorders the cuts according to so it basically orders them so that it's one contiguous edge that is made from the cut. So that, I mean, that can be generalized to any cross-sectional area. It doesn't have to be a and I mean, for example, it does it the same way with the fuselage as it does it with the wing. So it's already generalizable in that sense. So you can, instead of calling it compute airfoil section, you can call it compute cross section, and it would be doing the same thing.
Okay. Yeah, that's very good to know. Yeah.
Yeah. And so yeah, and we have to try and think of some other sort of generalized geometry evaluation that we can do. Thickness is one of them. If you just specify for example, XY or YZ location, it just sort of shoots a ray through the geometry and calculates the thickness at that location. I mean, that's a very easy generalized constraint to implement.
Okay.
So I mean, and if there are any more like sort of examples of this and things that we think about, we can add them. But if you're trying to make a general optimization framework, I think it's good to have some general geometry evaluation parameters as well.
Yeah.
This third one is expanded DV definition capability. I know we don't want to put cconfig refactoring in here because it's a huge undertaking in itself. So I would just be happy with having a sort of extended FFT handling feature. And I was thinking about this, and I wasn't sure if, for example, we aggregate FFT points in Python. How do you get gradients of that from the C++ through automatic differentiation, algorithmic differentiation? Sorry.
If you do it on the Python side? If you, for example, translate an entire section of the FFD.
Yeah.
Well, I mean, if you do it on the Python side, you would need to do it manually, I suppose. It's not difficult. That kind of transformation is just it's just a vector. So
but you have to sort of how do you propagate the gradients through to the to that design variable as opposed to the individual FFD points?
If you do it on the Python side, you need to implement that manually.
So you take the gradients from each of the individual FFD points and then project them onto the design variable that you are using.
Yeah.
Is that right? Okay. So that would again, like if you were thinking in the framework that you have, that would be one of the gradient evaluation steps to get the gradient with respect to a particular design variable.
No. I actually have an example of that. I will probably not be able to share my screen, but I can try.
Let me stop sharing mine.
We can try. Maybe we're lucky.
Yeah, I did the whole setup of enabling sharing, closing Chrome, opening Chrome again before joining the meeting. Let's see. Let me try and find that script. But essentially what I do is to define a variable object, and call it. This would be your translation, and then this thing knows that it needs to do a transformation when it to affect multiple FFD points and do the opposite when reading the gradients. So
is it really necessary to have that in Python? I mean, what would be the advantage of having like these things in Python rather than having that in C++?
We can implement. There's already some of that in C++. I don't know how to use it, but I think there's already some of that in C++. You can define camber variables and twist variables.
Oh, okay. So you mean like additional design variables that are based on the FFD box?
Yeah, they're built on top of the FFD.
Yeah. So like the classic example I think of is like the span of a wing. Like that can easily be done through FFD box, like an aggregation of how you move the FFD points.
Yeah, but the question is does it make sense to have that in Python, or should we implement that in C++? I mean, how often do we have to define new design variables based on FFD? I think that's the question, right?
Yeah, and I think the reason why the case for moving it to Python is to be able to define arbitrary design variables that you choose from by aggregating these things. So yes, it's not like it would be good if someone came along and thought of a new way to constrain FFD boxes and create a design variable based on that, which is why I want to move it to Python, is to allow someone to be able to code that up if need be.
Is this thing sharing now or not?
Yeah, that works.
It is?
Yeah.
Yes.
Woohoo! Yeah, so this is what I do. There's a chord variable and there's a chord in translation, which I think matches exactly what.
Oh, but your mouse is not moving. I don't know whether you're showing something.
My mouse is not moving. What? But you can see. Can you see a Python script?
Yeah.
Yeah. But I thought that you were showing something, that you were moving your mouse somehow. But because it seems like a frozen.
I am.
Okay, then we don't see that.
That's fine. I think we can.
And the highlighting, do you see the highlighting?
No, we see just
this GC thing. Well, anyway, this you have a chord variable that what it does is to take a section of the FFD and stretch it, and you have a chord and translation variable which does two things. It does the chord, the stretching, and then the translation, which is just moving all the points by the same amount. And this and all this come from like a very simple base class, which is a vector transform, I called it. And so this thing, when it writes the values, it takes the coefficients. So the coefficients are the vectors of the coefficients are arrays for this transformation. So it's just a set of weights that you take the value, the chord change, you multiply by the vector, and then you set a range of values for the FFD instead of setting just one. And then when you do the reading, this kind of operation, it's just differentiated manually. It just do a dot product of the coefficients you have with the gradient of those points. So, but I mean, once we have it on, we just, if we have this abstraction of this variable kind of abstraction, the users can then code this themselves.
Yeah. Okay. So that you mean then that we have the kernel in C++?
Yeah.
But everything else then is exposed to Python.
Yeah. So the part that it does the parameterization and then the reparameterization once you change the FFD box and moving it from Cartesian to parametric coordinates, all of that is done in C++. Just the way you just define the way the FFD points move. You can define specific ways in which the FFD points move, just like Pedro did with the chord variable.
So that means you essentially just set the coordinates of the control points.
Yeah.
Like from within Python, and that is passed to C++.
Yeah. And you can superpose different design variables based on that. For example, if you have with the same FFD box, you can have span variable change where the Y location is, but you can also have just those FFD points also constrained in just the Z to change the shape of the wing, the local shape of the wing.
Okay. Yeah, I mean, I like that idea.
Yeah, and I think because FFDs are so generalized already, I think it's useful to have it in Python, because then you can do things like this, like the code variable, and without having to go through the process of adding a design variable in the C++ code.
Yeah, no, that sounds very good. I mean, that is also not that much work then on the C++ side, I think.
No, it's just a little bit of refactoring to make sure that the FFD script instead is like separate from, it doesn't require like a config object or a geometry object.
Exactly. Yes.
You just need point clouds, and so it's just a little bit
So,
of
so what we're moving into is to have SU2 Dev takes in. So in terms of defining what are the inputs and outputs of each element, we have SU2 Dev will start taking a cloud of points and as the or a pair of points and displacements as the input instead of taking explicit design variables, right? Or concrete design variables.
Yeah.
Okay. Yeah, that makes sense to me. Yeah. And then would you have because then you need to take the derivatives with respect to this cloud of points, right? And then do the chain rule with the FFD. Would you have that in C++ or in Python?
Which chain rule are you talking about when you aggregate the variables? When you aggregate the
No, when you look at the mesh deformation right now, so if you look at what it does right now is you take the input variables from the config, and this can be FFD or Hixene or whatever.
Yeah.
Then you compute the deformation of the surface, and this would be your cloud of points, and you apply that to the volume, right?
Yes.
So and then SU2 dot does the reverse operation. So what we want to do is to break this into more steps to give a bit more flexibility. Is that it? So we have the deformation part that doesn't take design variables. It takes a cloud of points.
Yeah.
And if the cloud of points happens to be your design variable, so be it.
Yeah.
And you have you have a FFD, a general FFD that just manipulates this cloud of points.
Yes.
And so on the interface between the FFD and the deformation, you have some derivatives that you need to propagate, right? And will that be on the Python side or the C++ side?
I would say that that's on the Python side, then, to like get the sensitivities out of the mesh deformation part and pass it to the FFD part.
Yeah,
Yeah, that makes sense to me.
Yeah, I think that we'd have to do that.
But
so because these should be separate tools, right, or separate modules.
I think we can separate these, because then, like you said, you get the surface deformations, which means you have surface coordinates plus some coordinate variation, and those then get passed into the volume deformation scheme, which does the linear solve to do that.
Yeah.
Because then we can also think about like moving, for example, the Higgs-Henne entirely to Python. because that actually doesn't require like a lot of complicated things.
Oh yeah.
And the derivative is also very simple. So
oh yeah, because those are just literal functionals, right? That you place into.
yeah, exactly. Right.
Yeah.
So we don't need like a C++ module that is responsible for Hexena or something like that.
Yeah.
Or for rotating things as well. Rotating maybe, because that maybe is a little bit more involved. Yeah, we have to see how we do it with with other design variables then.
So I think having at least the FFT stuff outside would probably make that minimum viable product.
Oh, we can even move rotation. Is like you can also do that with FFD, right? So
yeah,
in the end, we can move a lot of things to the FFD.
exactly. Yeah. So if we move the FFD stuff like that, then you could do full rotations of things as well. Rigid body rotations with that. Yeah.
Yeah.
It's just that in terms of setup, I don't know. It's if all you want to do is some rigid rotation translation, so on, it's easier to do that. It's easier to do that the setup for that than to do a whole FFD setup and then yeah.
I mean, you can easily automatically generate like an FFD box for that.
Yeah, that was the other thing that I wanted was also.
Yeah, but there's a series of things to consider there. The first is that first you need to find what's the volume, what volume you need for the FFD, and that volume needs to consider the final position of the surface as well. It's not just enough to like surround to make an envelope of the initial shape. You actually need to have enough room inside the whole FFD to cover all the deformations. Otherwise, your derivative will not be computed properly at the moment, right? Because what we do with SU2 Dev is you move the grid and you also move the FFD parametric coordinates. You also update the FFD definition in this new deformed grid, and it's in this new FFD positions that you then evaluate the derivatives of the FFD when you run SU2 dot. So yes, we can do rotations, but
I don't understand the problem. I think.
Okay, so if you move, imagine you have an airfoil, and you move and you deform it in a way that the deformed shape is outside the FFD. Okay.
Yeah, but that cannot happen.
It can and it will. Of course, it can. Why not? There's no limit on how much you can move the points. You can move them outside. You will not be able to.
They can end up outside. Yes, yeah, it's true. Yeah.
But then when you do the differentiation, you will not be able to differentiate the points that are now on the outside of the box.
That is true. Yes.
So if you want to do a rotation, you need to make sure that the box is big enough to cover the entire path of what you're.
Yeah, that's actually true. Yes.
Okay.
Yeah, okay, but these are small details.
Yeah.
So it's all things to consider.
Yeah, but it's good to think about these small things. Yeah, okay, I see the problem there. Yes.
Yeah.
Of course, we can also have like a tool that does like rotations and stuff like that. Of course, because because it's not complicated. But,
yeah.
Okay.
Yeah. So back to the minimum viable product. In general, do you guys agree with these targets that we can set ourselves? The fourth one is interface with C++ objects. This is just a basic target to be able to use the in-memory Python structures as opposed to file I/O.
Yeah, so for all the points before, right? For
Yeah.
point 1, 2, and 3.
Yeah, this is sort of encompassing all of them, yeah. And that it should have a user-friendly UI. That's
you can always set up like a UI after like we have finished 1 to 4.
Yeah, exactly. So this is user-friendly UI here can even mean just being able to specify things with an input text file, as opposed to just so that it's available for people who are not Python coders.
Yeah.
Let me write that.
Yeah, well, I mean, so long while the previous not previous current while the current framework still works, like there's nothing holding us back of starting releasing something that it's not fully user friendly, or
I mean, it kind of works, right? So that's always the problem.
Yeah, I mean, for master students or whatever that never coded much, and their professors tell them to go run a shape optimization on something. Yeah, it's good enough.
The old one as long as possible, because they should not interfere that much with.
Okay, yeah. The rest I had just some sort of small tasks based on the work packages that we that I thought about earlier. Which is just a geometry evaluation, variable definition, and optimization framework. Mm-hmm. I've chosen these three because they don't overlap, and you can work on them separately. I thought that was the easiest way to divide the work up. The user interface obviously it requires all three, so that's sort of the last step in this process. Yeah, these points are already in the Word doc, so I'm not gonna go over them. The one other thing that there were some decisions to be made was whether we're gonna do PyOps parse or some other Python optimization interface, whether we want to create wrapper classes as opposed to expose full C++ classes, and things that we're putting on the back burner for now, for example, cconfig refactoring.
Yeah, so I mean, regarding the PyOps parse, I don't see a reason why we should not use it. I think that's one of the few optimization packages that is still maintained and offers like a variety of different optimizers.
Yeah.
And even like
I think my only recommendation in that direction would be not to make it or try to have a set of base classes that allow us to put together interfaces to different optimizers easily. So trying not to stick to the PyOps parse requirements too heavily or exclusively.
Yeah. No, that makes sense, I think. But we can provide that as the default.
Yeah.
Because it's also on GitHub and it can be easily like pulled and or cloned and stuff like that. But you're right. We should have it general that people can stick it into their frameworks.
Yeah. Most of them just require callable function. Most Python packages that I've seen with optimization frameworks require callable functions that can give you objectives and gradients. And so if we can create that sort of abstraction, which I think Pedro has done to a fairly good degree with Fader, I think we can easily port from one optimizer to another. Easily being a relative term.
No, it should be easy. I mean,
yeah.
From a hacking perspective, it's very easy. It's like you said, all you need is some callable thing, and that's it. Despite the whole in-memory classes and objects, we're still going to have some file output at least, right? We're still going to be, at each evaluation, we'll still have the option of writing the output files that we usually do. Or what's the idea?
But I would say we automatically disable like the visualization files, stuff like that. But you can, so that they are just restart files essentially, but you can then generate the.
Yeah, I was actually thinking along those lines. Was for intermediate designs to just have restart files so that you can recreate the surface and volume representation if you need. But in general, having output visualization files for initial and last iterations, maybe.
I don't think we should touch any of that. We should take whatever the user puts in, and
you're right.
And let it be done. We don't touch.
But I think you were also referring to the mesh, right? Because if we don't have the incremental, or if we have like an incremental approach, then we have to write out also a mesh well, it's done anyway at the moment, right? Yeah, so it's not really a problem, I think.
So for this in memory, for this in memory things, would we have? I don't know enough about this, but do we have the primal and the adjoint all in one thing? In one object, one single object we call, or will there still be a difference between doing the primal run and the adjoint, or?
Well, we could do both, keep both in the same scope.
Well, so it doesn't, like, not every evaluation will require an adjoint calculation.
Exactly.
So you'd have to separate them. I mean, the gradient evaluation has to be separated from the objective evaluation. I'm not sure what you mean, but I think like the way the meshes are handled it always takes it from the base mesh. And I don't think we need to change that per se.
I don't think we shouldn't.
Yeah.
I think it's good to have, one reference.
Yeah.
Otherwise, the only way to repeatably recreate your design is to apply all each and every individual deformation steps.
Mm-hmm.
I would say that we in changing these things, we could try and maybe change how things are computed, because, for example, right now to differentiate to do the projection step in SU2 dot, you need the deformed mesh. We use the deformed mesh, but ideally ideally, if we could, we would use the original one.
Yeah.
So we would do everything. We would do everything from the original, and ideally the FFD would be differentiable from the original position as well. Because that would get rid of this problem of if you move the points outside of the boxes, then you cannot get the derivatives anymore.
Yeah.
So instead of differentiating the FFD around all the points, all the DVs being 0, which is what we do now, maybe we could try and differentiate around the actual coordinate.
Well, that would be also the goal if we have it like all of that in memory, right? I mean, since we always work with the same geometry object,
yeah,
at least that's what I think how that should work.
It would be great if we could do it with just one geometry object, because then you don't have to pre-process every single run.
Yeah, exactly. That would also like.
I made the pre-processing very fast now.
Oh yeah, I have to test that. Well, that's really much faster now.
Yeah.
Yeah, no, but that's that would be the goal, I think. So that we still need like 2 geometry objects because of the adjoint.
Mm-hmm.
So we have to probably keep 2 of the geometries in memory for the whole optimization, I think.
Okay.
Okay. So that is not passed as that will never be passed as a file then. That will always be directly in memory. We pass the new.
Yeah, that's what I thought. I mean, of course, that's up for discussion, but
that was
my idea.
Yeah, that was one of the things that I also wanted to discuss, is how exactly the running goes, whether we have whether we need to instantiate a driver for each iteration, or whether whether we can work with just one geometry object. If we can, that would be amazing, or 2 in this case. But
yeah, I mean, this was what I assumed essentially.
Yeah,
that it is done like that, but I don't know what implications that has for all the other stuff.
Yeah, I mean, we'd have to think about this a little more in terms of the full ramifications of what this means, and what would be required to be done, because you have to be able to move the geometry from one place. Actually, if you have the same geometry object, then it only stores the original points and then the variational coordinates. So
yeah, I mean, ideally geometry should like not really change except when you update the geometry or when you move the mesh, but in between everything should be constant.
Yeah. And we do need a separate one for adjoint and direct. Is that?
Not necessarily. You can, of course, also run the primal solver with the differentiated stuff, but then it is slower. So it's not ideal, I think.
Okay. Yeah.
Because we have an overhead between 1.5 to 2.
Okay.
Yeah. So it's
okay.
So if we have the memory, and I think that usually we have, if we want to run a discrete adjoint anyway, then we should have 2 geometries.
Okay.
Both the geometry and the new mesh solver, which I guess we should try and use for all of what we will do now.
Yeah.
They're able to keep track of the original points, which is all you need.
Oh, right.
So
What about the new mesh solver?
You don't even the old even the geometry structure itself has a lot of coordinate old and coordinate n n1 n minus 1 n plus 1. So there's a lot of space to save there, just the original mesh when you start the optimization, and then every time you do the deformation you can just restore that and apply the deformation on that. It shouldn't be. We shouldn't need two. Basically, we shouldn't need two geometry objects, I think.
No, but I mean, we need two because of the adjoint. That was the
why?
The reason.
Why do we need one for the adjoint?
Because it needs the differentiated version.
Yeah, exactly. And you deform it.
But what I mean is that you have your primal evaluation, so you evaluate your objective function, and therefore you need the non-differentiated version, and then you do the adjoint run, and you need the differentiated version. So you need like these two.
Yeah. Okay.
Like I said, you can also run the objective function evaluation with the differentiated code base, but it's slower. So I don't think that it makes much sense. So this is why we need two. But yeah, of course, we also need the initial one, and since that's stored in the solver, that I guess makes sense. But that also means we need two of the mesh solvers as a consequence. Well, actually, not necessarily, because it's just linear, right? Well, not really linear. I don't know. Someone wants to speak. I mean, you can speak.
Yeah.
Yeah.
Well, these I guess just need to be a little more hashed out, but I think those are.
We could optimize it also later. So I think in the beginning we need like 2 copies of everything.
Yeah.
Well, two or more possibly. If you have different operating points or whatever that you want to do, you might need more than one solver.
Yeah.
Oh
yeah.
Unless we have some way to change boundary conditions or whatever.
But we can leave that later. But up until then, we could probably just.
Maybe we can think of reusing like the Jacobian or something like that. I don't know, because this is where most of the memory goes. But yeah, it's something else. Maybe this is just like something we can optimize then later.
Yeah.
I would also like to maybe add another aspect, which is finite differencing and direct differencing for gradient validation, because if the shape optimization framework is completely reworked and it moves to another home, that also probably applies to everything related to finite differencing and direct differentiation. So I'm not sure whether there are already plans for that, because the Python scripts all use the same like Python backend. So I'm not sure what is the plan with that.
So if we have like this general framework to evaluate like objective functions and stuff like that, then implementing finite difference should be very simple.
Yeah.
Okay. So yeah, that of course. I mean, since we want to remove like the old Python stuff, we also have to port like finite difference and forward mode. Right? But like I said, that should be quite simple.
Yeah, and would that then be in C++ code, or would that still be Python?
Yeah, that would be also in Python then.
I guess whatever modules we have for primal and adjoint, we would have for forward. Yeah, and that would be it.
Exactly. Yeah. So once we have the framework, I think it should be very simple, or at least that's what I hope. That something like that would be very simple to do then, because you can just stick together the different Python or exposed Python functions to achieve that.
Yeah.
Yeah. Okay.
Okay. Was there anything else? I didn't have anything else to discuss. I know this ended up being a full meeting now, but.
Hey, can you guys hear me?
Yeah.
Yep, Tom, we can hear you. Hi.
Okay, I have a topic just for the end that I think we need to start discussing. We have the developers meeting coming.
Yeah, well, 1 second. There's some background noise here.
We need to put together some tutorials, and so I thought we could just spend a few minutes discussing what all you guys think we should put together, how to organize that work. Because I think we already had a couple ideas, like maybe Pedro, if you're willing, talking a bit about the OpenMP or performance issues. Giant, maybe you could talk about shape optimization. You know, I could put together one for development or update the one that we've used in the past for development, etc. So do you guys have some ideas? Do you have a minute to discuss?
Yeah, I actually asked about I asked about this in the beginning because I got an email from Juan saying that if I would like to extend my presentation to about 1 hour, that's what you guys have in mind for the tutorials or classes, right?
Oh, there he goes. That was too much.
Oh, there he is.
Are you back, Tom?
Can you hear me again? Sorry about that. As soon as I finished talking, it kicked me off.
No worries. I was asking, so because I got an email from Juan asking if I would like to extend my presentation to make it a, what do you call it, a class of sorts, or I don't know, to about 1 hour. Is that what you guys were thinking for these tutorials?
Yeah. So I hope you can still hear me. My computer's being very funny. Okay, good. So yeah, what we had in mind, I even lost a little bit at the beginning, but I heard the tail end of your question. But what we had in mind is for the whole meeting, we don't know how many folks are going to want to give lightning talks yet, but the idea is we'll break into probably 2, 3, 4 sessions that will span maybe 2 to 3 hours. And for the first hour or so, we can have a tutorial session led by one of us. And then, or we'll have an overview presentation, a couple other things. So reserve maybe an hour or so at the beginning of each session to do something like that, and then leave another hour or 2, depending on how many people want to give lightning talks, for the lightning talks and discussion. So that's sort of what we had in mind.
Okay. Yeah, and the format for this is we'll just put together a presentation, and then we will talk over the presentation live.
Yeah. I mean, unfortunately, we're stuck with all we can do is virtual. So not too different from what we do in these meetings, actually. I mean, if you have slides, you can just walk through. Maybe you can even do a live demo if you're really gutsy and want to give that a shot.
Oh yeah, absolutely. Less coding, yes.
Yeah, that's the idea. I mean, we've done these in the past, kind of had workshops on the side of the meeting, or even just workshops independently where, each person puts together something and then you have your chance to walk through it. So
Okay. Yeah.
And it's kind of up to you guys. I mean, we can adjust. I mean, what do you guys think we should show? Those were just our ideas, but I think it would be great if we had 2 to 5 sort of pre-made 30-minute to 1 hour tutorials to explain things to folks.
Yeah, I can do.
If Pedro could give some overview on the OpenMP stuff, I think that would be wonderful. Like I said, maybe like including some small OpenMP tutorial for people who are not familiar with it. I think that should be quite fast, I think. But yeah, I think that would be very helpful.
Yeah, that sounds good.
But we have to think about what we need.
Topics.
Yeah, exactly. Well, some basic introduction, I guess, would be good, I think.
In what do you mean by that? So in terms of running the code or doing optimization or doing development?
Well, so maybe it would be good to start even with compiling the code. I mean, we could also use that videos because we post them on YouTube anyway, right? So that's also helpful for people who are not really attending live. So also for people who just
absolutely
try the code and stuff like that. So maybe it would be helpful. I mean, we can also do that on the side and then extra, but maybe it would be helpful to see how the build system works and how to set up like an environment. Also, maybe to start developing and stuff like that. I don't know. That would be my thought. So setting up the environment to start developing, essentially.
Tips and tricks to write good code.
That is like a topic on its own.
Exactly.
Well, we can. Yeah, I mean, I don't know whether maybe that's out of the scope for the conference, but at some point having like some basic like programming tutorial would be also not bad, I think, but probably not for the conference.
Yeah, Tim. So on your idea for getting set up for development, would you be interested in updating my old presentation on how we do development? Because it's been a couple of years. It probably needs a couple things. So you could intro a build system.
What format do you have the presentation? Okay.
Oh, I'll have to go find it. I'm afraid it might be Keynote, but we can always convert it to PowerPoint or whatever you please. I could try to get it into Google if that's better. What would you like?
Yeah, Google would be. That would be the best, I think. Yeah, sure. I can update it. Maybe we can use that for the beginning and then show how to build the code and the build system and stuff like that. Yeah, so I think I thought about like people that we can teach also people about some tools and stuff like that, right? So the build system can be also useful for other things. So yeah.
Yep, that sounds great. So other things we can do. I mean, in the past we've gone through like somebody giving an analysis tutorial, like pick a case and walk through a config file or something. We could do that for shape optimization. I mean, I'm just looking at our old workshops.
Yeah, I'm not so about the shape optimization. Since I'm not so convinced about the Python framework that we have at the moment, it's hard for me to give like any tutorials on that.
Yeah, maybe a multi-zone case walkthrough.
Yeah, that'd
be great.
Yes, yeah. Maybe not an optimization, but at least like the analysis.
Yeah, I mean, just how the meshes splitted the config files. And
can you do that together with Ola?
Yeah, sure. I just wanted to say that because I think it's also I'm not sure how well all that is documented on the website with the inheritance of the config file options to the like child config to the child config files and so on, so that so what you have to look out for if you set up a multi-zone case. And of course it would be a CHD case, but hopefully most of it applies also to FSI.
But that depends on what kind of multi-zone evaluation you want to do. Because if you want to use SU2 Dev or SU2 Geo with a multi-zone case, you're gonna run into some problems that you don't run to when using SU2
We just talked about the analysis, I think.
Yeah, it's
so not optimization.
Yeah, because to my knowledge, none of that currently works with multi-zone cases, right? So
yes, it's limited.
Yeah, either way, though, I think an analysis would be really, really great. I think we have only maybe a couple tutorials that talk about it, but we haven't covered it much in any previous workshops. I think it's time to have a little more, and a video would be great, or a walkthrough would be great.
Yeah, yeah. Also, how the
Toby,
output
can we put you?
like that.
Yeah, the output. Toby, can we put you down? I guess we'll have to also ask Ola, but
yeah, sure. The conference is on the 10th of June, right?
Yeah, 10th through 12th. So we haven't set a hard agenda yet because we don't know how many folks are going to want to give lightning talks. So I can't tell you the times yet, but we can work with you. We can obviously move these around and make sure everybody can make the sessions or whatever. So
yeah, I mean, it's just about like having a month. That was the information I needed.
Yes,
the exact time and date, that's of course not so.
I mean, you don't have to
don't feel too much pressure.
It's okay if you just walk through like a setup.
Yeah, try to maximize useful info with minimizing your time to prep. So. Okay, another thing we've talked about in the past is mesh adaptation. We could have somebody show AMG plus SU2 for mesh adaptation workflows. I think Brian has been working on that a lot. Any other ideas, guys? So like big ticket items that would be really good to show.
Unsteady stuff is really important, I think. Also in combination with the scale resolving things.
Right, yeah. We should ask, I can ask,
Eduardo and Beckett.
Eduardo, yeah. Yeah, that's a good point. Okay, I'll note that down. I'll email Eduardo.
We should have, but if you ask Beckett, then make sure that you avoid the terms acoustic and aeroacoustic.
Because that would not be SU27 anymore, would it?
Exactly. I'm sure he would love to talk about it. Okay. Yeah. Yeah, but that would be an interesting topic, I think.
Okay. I mean, that's already 4 solid ones, maybe 5. I don't want to suggest too many and have people prepare, and just in case we don't end up needing all of them, but 4 or 5 would be really good, I think.
I mean, we record them anyway, so I think that nothing is lost if we have more than we actually need for that time.
Yep. Okay. All right, then I've got those noted down. Maybe I'll send a follow-up email to you guys just about it, and then. But yeah, start giving it thought. We got about a month, and like Tim said, it doesn't have to be, the most fancy set of slides you've ever put together. Just start thinking about what you would walk through and prepare some cases or something. So. Okay.
Yeah, good that you mentioned that.
Okay. Yeah, we can check in on that topic in the coming weeks when we have these meetings, if anybody has questions or concerns or something. So.
Yeah. Okay.
Okay.
Then, if there are no other things,
That works.
Yep, all good for me.
Thanks, guys.
okay, cool.
Okay.
Then, thank you very much, and then until next time, I would say.
All
Yeah.
right.
Okay.
See you next time.
Thanks, guys. Later.
Yeah, bye.
Bye bye.
Bye.